Okay, the second row operation we discussed was times row plus. So when we look at the directions in example 5, it says change the first equation by adding it to -2 times the second equation and give the abbreviation of the operation. Like I said before, I prefer to work with the augmented matrix. So first I'm going to write the augmented matrix represented by this system, 2, 3, 8, 1, 5, 5. And I need to multiply -2 times the second equation. So what I'm going to do is I'm just going to squeeze in these values here. -2 times 1 is -2. -2 times 5 is -10. And once again, -2 times 5 is -10. So what I need to do is I need to add these two rows of values to get my new row 1 values. So 2 minus 2 gives me 0. 3 minus 10 is -7. And 8 minus 10 is -2. And the second row does not change because it said in the directions just to change the first equation. So in our row operation abbreviation, we write the changing row first. So row 1 changes by adding it to -2 times row 2. So that is the abbreviation. If I were to draw my arrow in, I would write that same thing or a slight modification. Row 1 minus 2 times row 2. And finally, the third operation that we'll perform on matrices and using our Gauss Jordan elimination is to interchange two rows. So these directions tell us to interchange rows 2 and 3. So the row operation requires us to write row 2 with a double-sided arrow and row 3. And so I think I needed to scoot that over a little bit, but I'm just going to squeeze it in here. Row 2 and row 3 interchange places, so that means row 1 doesn't change at all. And I missed my augmentation there, so please draw that vertical bar into your notes. So now, when I'm ready to move to row 2, I need to take the row 3 values and put them into row 2. So that's 0, 1, -1, 2. And I need to take the current row 2 values and put them into row 3. So that's 0, 0, 2, 7. If I were trying to transform this system into reduced row echelon form, I look at my principal diagonal starting with row 1, column 1. That's a 1, and the rest of the entries in that column are zeros. So column 1 is dealt with. So I move down the principal diagonal to row 2, column 2. That's a 1. The other entries in that column are zeros, so this column is dealt with. So I move once more down the principal diagonal, and I see that I have a 2 here, and I know that it needs to be a 1. So with the 3 row operations discussed, you'll need to decide which one of those can you use to change a 2 into a 1. Sometimes I'll ask myself a question like, 2 times what is equal to 1? Well, solve that equation by dividing both sides by 2, and you get that you multiply by 1/2. So therefore, the next row operation would be to multiply 1/2 times row 3, because we want to change the 2 into a 1. And so if I did perform this row operation of 1/2 row 3 times the previous matrix, then the first 2 rows would remain unchanged. However, the third row, when multiplied by 1/2, would become 0, 0, 1, and 7/2.